Awesome. Thanks, Mark. Just share my screen here. And yeah, just double check that you're able to see my screen.
Yeah, Zach, it's coming in well.
Awesome. Perfect. Thanks a bunch for the intro. Yeah, so I'm going to be giving a presentation here going through our semi-quantitative rockfall risk assessment tool. I'm going to be talking about its applications for highway corridors specifically, and also its implementation in our geohazard management platform, Cambio. Yeah, so just a bit of background for those of you who might not be familiar with them. Rock slopes are a geotechnical asset. They pose risk to a variety of infrastructure types. Today we're talking about highways specifically. Transportation owners are responsible for managing rockfall risk to operate a safe and efficient highway network. They only have limited resources though, and so they really need to decide how to allocate those resources for mitigation and maintenance responding to rockfall events. And this has traditionally been done using rockfall rating systems and rock slope risk assessment systems to kind of prioritize where they need to focus their efforts. So like Mark was saying, since 2020, BGC's worked with CDOT on an update to their geohazard management plan, their GMP, which has really been focused a lot on rockfall hazards. There's a really great photo here of a 1,000 cubic meter rockfall event that destroyed a section of highway in Colorado back in 2019. So they're really focused on trying to avoid having these sorts of things happen. So the project goals, CEDAR has an existing system for managing rock slope risk, but we want to focus on different ways to improve this. And so there's kind of three pillars or boulders in this case that we're focusing on in improving their framework. We want a probabilistic system that's focused on the likelihood of future rockfall events of varying frequencies and magnitudes. We want a multi-consequence system. So traditionally, these have really been focused on safety risk, but we want to focus not just on safety, but also on closure of the highway, so impacts to the traveling public, and then also direct costs to the actual operators to clean up the rockfall debris or do repair work on the highway that's been impacted. And we want to quantify this risk in terms of dollars and express it annually so that it can be used for, critical management decisions like cost benefit analyses for mitigation and things like that. So the framework that I'm going to present is it's built on BGC's experience with quite a few different rockfall hazard and risk assessments for a variety of project types, especially in our railway sector. And this algorithm is really the first of its kind in Cambio for highway specific projects, which is something we're pretty excited about. So before I get into the really detailed kind of framework, I just want to talk about like the fact that this is a risk-based assessment and just some of the kind of more simple questions that we want to answer for those who might not be familiar with this sort of risk chain approach. So we're going to try and move from like credibility to risk. So we'll start off with, is a rockfall event a credible hazard at the site? Like, is there a rock slope there? Could a rock even fall? If it can fall, how often do we think that it may fall? If it is going to detach from the slope and fall, what are the chances that it runs out and actually hits our asset, in this case, the highway? If it does reach the asset, will it result in some sort of negative impact? And how bad will that impact be? So that's really fundamentally what we're trying to do with this system. So this is an overview of the framework that we've developed together with CDOT to try and kind of, like I said, improve on the way that rock slope risk assessment was being done. So it kind of starts with hazard on one side to start, and there's a few key terms that we're going to try and get at. So first off, the overall rockfall frequency. So how often does a rock, regardless of its size, detach from this slope? And then we want to think about the sizes, so the frequency magnitude. Are they kind of small baseball-sized rocks that are falling off? They're big house-sized boulders that could detach from this slope because the implication is, of course, different for the highway. Is there anything in between the slope and the highway? So, is there a ditch there and is it effective? Is there some sort of mitigation, like a concrete barrier or draped mesh on the slope that would reduce the number of rocks reaching the highway? And then that really kind of sums together to give us the number of rocks that could reach the road per magnitude class per year. We're going to then cross that with the various consequences that we're considering. So the first one is safety. Like I said, that's traditionally where these systems have been focused, trying to prevent rocks from impacting the traveling public. There are two scenarios we consider. So there's the rock hits car directly scenario. So we're trying to determine what's the probability that when a rock falls and reaches the roadway, is there a vehicle there that might be impacted directly? And then also scenario where rock falls on the road, car comes around the corner, they don't have time to stop, they crash into the rock. So those are the two scenarios we're considering for safety. And we cross that with the cost of a statistical life to get our fatality risk annually in dollars. The next consequence, and I think one of the most interesting ones that isn't really considered as much because it's quite difficult to quantify, is user cost. So what's the cost to users from the road being closed, either fully or partially, resulting in them having to take a detour around that section of highway. So this considers things like the volume of traffic on the highway, the speed of the vehicles, how long and painful that detour might be based on the size of the event, or how redundant the highway network is. And then that's quantified using the value of the driver's time and then also the cost to operate their vehicle. And that gives us our lost wage and vehicle operating cost. And then last, we have our owner costs, and that's a combination of maintenance that needs to be done to clear up the debris, as well as, how basically costly is it to repair that section of highway. We sum all those together and we get our annual risk exposure expressed in dollars. And so previously this was really just focused on like, we had an event at the site, how costly was it last time? Okay, that's the risk at this site. This is a more forward-looking approach, and it's really considering all these different consequences, and it can be used now for cost-benefit analyses. Now, that framework, that was even an abstraction of quite a lot of math that has to go into calculating all those different values to come up with the dollar value per year. And previously, we were doing that with just a gargantuan spreadsheet. It was hard to keep track of the versions. It was really hard to share with our clients. Only BGC was comfortable using it. We weren't going to share it to CDOT's other consultants to use. And this is where Cambio comes in. We've now implemented this framework directly in Cambio, our geohazard management platform. And that allows us to really operationalize this tool and connect it to this database that CDOT has in Cambio of their highway and then also all their geohazard sites. So all the green lines are CDOT's highway network across the state of Colorado, and each one of those purple points is an inventory geohazard site that we've worked with CDOT to get in here, many of which are rock slopes. Now that we're in here, we can zoom right into any rock slope we want. We can see some information in the form of the rock slope on the side if we want, where it's located along the network, what type of slope it is. This could be not just used for rock slopes, we're also using it for embankments, steep creeks, things like that. And then we can basically attach an inspection to that rock slope. In this case, the inspection is how we collect the information we need to do the risk assessment. So this is just showing kind of a summary snapshot that an inspection has been added to this site. And you can see kind of that we've computed this like resulting, hazard frequency. So that's how often rocks are going to reach the road. And then there's a grade. That grade is really just a categorization of the dollars of risk that the system's produced. And so we'll drill down now into the actual inspection and kind of see some of the inputs that go in there, and then also a more detailed breakout of that actual risk assessment. All this happens right in Cambio. So as the user fills out the form, it's running the hazard calculation and then using the highway data to produce a risk estimate. So one of the key things that you need to do at the beginning here on the hazard side of things is determine how many number of rocks are falling basically from the slope and what their sizes are. So to do this first, you identify what kind of rock mass type you're in, because certain rock masses are predisposed to produce different sizes of rockfall more frequently. Two examples here, a massive rock mass and a block and matrix rock mass, very different from a rockfall hazard perspective. And that puts you on one of these default rockfall frequency magnitude curves that we have programmed into Cambio. And then you also have to estimate the number of rocks that you think just in general reach the highway or fall from this slope. In this case, it could be looking at the ditch, it could be consulting maintenance records, things like that. And maybe you say they're yearly, one rock falls per year from this slope, or monthly, you have multiple falling per year. With the overall frequency and the frequency magnitude curves, we can then get an estimate of the number of rocks that are going to fall of a different size from this slope. But maybe looking at the slope, you don't think that the default literature curves are what you want to use. You want to actually adjust this manually because, looking at, say, this slope, for example, on the screen, there's some really large blocks that are available at this site. And so what you're able to do in the tool is actually kind of break out a user-defined distribution of block sizes, and it will blend that with the default literature curve to then give you this adjusted site-specific curve. And that gives you kind of a more accurate representation of what the potential rockfall hazard is at this site. Now, that's just the number of rocks that are falling from the slope. It's not how many are actually reaching the highway. And that's where we need to think about the spatial probability part of the question. And so in this case, we consider things like ditch effectiveness. So if you're a rockfall practitioner, you've probably seen the Pearson ditch design charts. So the tool allows you to use those charts by basically answering questions about the slope at the site and the ditch as well. So how tall is the slope? What's its angle? What are the ditch dimensions, width, depth, things like that. And it'll give you the ditch effectiveness from the Pearson charts. Now, these charts are historically pretty conservative, so if you don't think that, it's capturing how effective that ditch actually is, you have the option in the tool to just override that. Now we can also add mitigation to the site. You can stack mitigations and it'll basically multiply in the risk chain and reduce the number of rocks that are reaching the road. So in this case, like maybe there's a concrete jersey barrier at the edge of the ditch. I think it's effective for smaller rockfall classes V1 and V2. I can leave a note about that mitigation and then that'll be captured in the risk chain. There's basically predetermined mitigation effectiveness values that are run through the hazard portion of the calculation. And you can stack as many as you want if there are multiple mitigation types present at the site. Now this all gets updated live in the tool as you're changing values, playing around with it. You can see what's happening to your risk estimate. You can also see the input parameters from the highway data set. So at this site, I can see what the average annual daily traffic is, the speed limit, detour time, etc. that are all going to feed into the consequence part of the calculation. And then I can see what my resulting risk estimate is, broken out into the different types of costs I was talking about, like safety cost and user cost, owner costs. And it'll also sum it together to give me that total annual risk exposure. And then in this case, it's categorized based on CDOT's GMP. They use the letter grade system, but this could be tailored to be, any categorization that you wanted for your program. Now that this is built into Cambio, it's really easy for CDOT personnel or CDOT's other consultants to use it, and it means that we can now roll it out a lot more easily to other DOT programs across the US or in Canada. One of the just kind of quick examples of the way a tool like this I think can be used is just doing a quick and dirty options assessment. Because you have all these different levers in the tool that are really easy to pull now that it's baked into this database that's also connected to all of your geo asset data and highway data. You can come in here and say, we filled out the rating once for the site. We got a D, so it's it's not a good site. It presents quite a bit of risk, over $60,000 annually from this one rock slope to the network. What if we increase the ditch capacity? What if I went in there and widened the ditch and, created a ditch that was more effective? And what if I added that concrete barrier? Okay, well, I can see now that I've, moved from grade D to grade C. I've dropped my risk, maybe 25K a year. But what if I want to take it a step further? I don't think that reduction was quite enough for the cost. What if we run a routine slope scaling program, which allows me to kind of reduce my overall rockfall frequency from F equals 10 down to F equals 1? I can add that into the inspection and I can see kind of in real time in Cambio like what that would do to the grade. In this case, it's moved it down to grade B, down to about $6,000 a year, so like an order of magnitude reduction from our initial assessment. So there's just one way that the tool can be used to kind of do like an options assessment and really support like decision making by DOT managers. So this tool was released this year in Cambio. We're really excited about it. It's something we've been working on with CDOT for quite a while. It's available in the web application and also in mobile. And we hosted a workshop in July with CDOT folks and also their consultants, and actually had people go to the field to rock slopes, use the mobile app, fill the tool out, ask questions. And this has been really great for us to get feedback on how the tool works and kind of some of the assumptions as well in the underlying framework. And so we're continuing to already incorporate and learn from that feedback. And it's something we're really excited to continue as we continue to roll this tool out. So of course, software is never done. In this framework, will never be done. We'll always be looking for ways to improve it. So we want to get feedback, as much as we can to leverage the experience of other industry experts, because it's been us developing this with CDOT, but we know there's a lot of rock slope practitioners out there who I think could leverage this and also give us really excellent input. We're going to be releasing similar algorithms, especially using that cost piece for embankment failure, debris flows, and also earth landslides. So look out for that. And there's just a variety of research opportunities here. We have these pre-built mitigation effectiveness tables that we'd really like to get input on from practitioners, some additional frequency magnitude curves for different rock mass types, that aren't specific to Colorado or BC. And then improvements to the ditch effectiveness charts as well, because they're pretty key to this whole assessment. So if you have any ideas or you're interested in using the system, you'd like a demo, please feel free to reach out. Thanks for the time.
And thank you so much, Zach, for your presentation. Any questions, we can put those into the Q&A, and I'll also put Zach's email in the chat for those that want to follow up. And just as a closer today, we'd like to thank all of our presenters, especially our keynote presentation to start us off by Kenichi. And I'd like to thank you all for attending. Enjoy the rest of your day, wherever that may be at, and look out for the webinar recordings. Those will be posted to BGC's YouTube channel.